Let's look at two titrations. The same acid, but tenfold diluted. So I'm going to take the weak acid, acetic acid, and titrate it with the strong base potassium hydroxide. That is plotted here in the dotted yellow line. Then I'm going to dilute by a factor of 10 and reperform the titration. Which is the new titration curve, A, B, or C? Think about that for a minute and make a selection. Let's look at a possible explanation for each answer. A, the pH should change by 1 unit at the beginning and the end, but the equivalence is unchanged. B, the entire curve should be lowered by 1 pH unit, a factor of log 10. Or C, the initial and the buffer regions resist changes in pH. Think about those three and make a selection. We're looking at titrating HAc, acetic acid, 2 times. One titration, then dilute by a factor of 10 and titrate again. Now, if you dilute by a factor of 10 the weak acid, initially the pH will change by 1 unit because the H3O plus concentration changes by a factor of 10. But remember, in a weak acid, there's plenty of undissociated HAc around that will dissociate after that dilution and lower the pH. So initially, the pH changes by less than 1 unit. Now, in dilution, you haven't changed the total amount of acid. So the total amount of acid is the same, so the total amount of base required to reach equivalence point is the same. In the buffer region, remember, buffers are also resistant to changes in dilution. You dilute a buffer by a factor of 10, but the ratio of acid to base is what's important in a buffer. And the ratio doesn't change upon dilution, so the buffer region is relatively unchanged. So here, the appropriate answer is C, a small initial change, buffer region about the same, and in the end, when the base dominates, just a factor of 10 dilution.